So now that we've looked at writing numbers in scientific notation, we're going to look at some operations of scientific notation. So this first video, we're going to spend time looking at multiplying and dividing. In a later video, we'll explore adding and subtracting. But let's start with multiplication. So let's start out with something like 8 times 10 to the 8th power divided by 4 times 10 to the 4th power. Okay, so two numbers in scientific notation that we want to divide. So basically what we want to do to begin here is we want to focus on those front numbers. Okay, and we know in scientific notation we're writing numbers as decimals. So in this case, we're just going to do 8 divided by 4, and we're going to get that to be 2, right? If you come out with like a number and it happens to be like 2.3 or 5.7, that's okay. We're not going to worry about writing it as a fraction or anything like that, because scientific notation, that first number is in decimal form. So once we've dealt with the first part, we then just want to focus on the powers of 10 there. Okay, we want to divide those. Now, previously we saw that when we divide powers of 10, so 10 divided by 8, 10 divided by 10 to the 8th power divided by 10 to the 4th power, our rule is that we subtract our exponents, right? So we're doing the same thing here. So if I have 10 to the 8th power divided by 10 to the 4th power, that's just 10 to the 8 minus 4 power, or more simply, 10 to the 4th power. So dividing is a pretty simple thing to do in this scenario, okay? Now, if you notice in this one, my front number, the top one is larger than the bottom one, okay? And it comes out to be really simple to do, okay? Let's look at a scenario, however, where that's not the case. So I'm going to create one where I'm going to make the top, let's make that 3 times 10 to the 9th divided by 6 times 10 to the 4th. Okay, so a little bit different here in that my front number, my top one, is now smaller than my bottom one. Okay, so let's see what happens when we follow those steps. So again, I want to deal with those front numbers first. Okay, so 3 divided by 6 as a decimal is going to be 0.5. Okay, after that I want to focus on, again, those powers of 10, right? 10 to the 9th divided by 10 to the 4th. Again, we want to subtract those exponents, and we get 10 to the 5th power. Okay, now what's wrong with that, you're asking? Well, if we take a look, right, this number is no longer in scientific notation. Again, scientific notation, that first number has to be at least 1, right? At least 1 less than 10. Well, right now it's only 0.5. So we have to fix that. Okay? So let's look at what we do there, and then we'll look at a pattern that we notice. Okay? So I want to take that 0.5 times 10 to the 5th, and I want to get that into scientific notation. So let's just take the first part of that. 0.5 is really 5 times 10 to the negative 1st, right? If I take that 0.5 and I put the decimal point where it's supposed to be for scientific notation, after the 5, I have to move it 1 to the left to get it back to 0.5. So a left movement is negative, so times 10 to the negative 1st, right? So I bring that down. Now I want to combine my powers of 10 together. So I want to take these two things and combine those. So I've got my first number right. It's at least 1 less than 10. Okay, 10 to the 10 to the negative 1st times 10 to the 5th. Again, our rule with multiplication is we add our exponents. So negative 1 plus 5 is 4. Okay, let's look at one more example of that, and then we're going to look for a pattern. Let's do 2 times 10 to the 12th over 8 times 10 to the 5th. There we go. Again, start with your front numbers. 2 divided by 8 is 0.25. Okay, and then we want to do times 10 and subtract our exponents, so that's to the 7th power. Again, not in scientific notation, right? 0.25 times 10 to the 7th, not in scientific notation, because that front number isn't at least 1. All right, so let's take that. If I take the 0.25 and I put the decimal point where it's supposed to be, right, the 2.5, okay, make that my front number. Now it's at least 1 less than 10. Okay, well, what did I just do to get it back to its original spot? I've got to move it 1 to the left. Right? So then I can combine those. So I end up with 2.5 times 10 to the 6th power when I add my exponents. All right. Now, if you notice what's happening here, let me flip back to a previous one. If you notice what's happening, right? So when I simplified, I ended up with 0.5 times 10 to the 5th. My final answer is 5 times 10 to the 4th. So I'm basically adjusting my front number to make it at least 1 less than 10. And then notice my exponent goes down 1. Right? I end up having to multiply by 10 to the negative 1st. If we look at my second example, the same thing occurred. 0.25 times 10 to the 7th. We'll end up making that 2.5, and then I've got to decrease it by 1, so 10 to the 6th. So kind of the shortcut for this, all right, when you divide, sometimes if you have to adjust, right, when adjusting, okay, that exponent decreases by 1, right? So you're always going to end up with one of two scenarios here, right? If that front number on the top is bigger than the front number on the bottom, right, and you divide those, you're always going to get that number between at least 1 less than 10, right? So in that case, no adjustments needed. Okay, we're just going to end up with 4 times 10 to the 4th, right? 8 divided by 2, 6 minus 2 gets us our exponent. Okay, where we need to make some adjustment, again, is those problems where we have that flipped around. Okay, my front number on top is smaller than my front number on bottom. Okay, so when I divide those, I end up with a number less than 1. Right? Again, our rule, our shortcut is, right, we got to get that front number to be correct, so instead of 0.5, we make it 5. And then our shortcut is we're going to subtract one exponent. We saw in previous examples, it's 5 times 10 to the negative 1st. So when we combine the negative 1st with the 6, we get 5. Okay, so that's division, right? Just separate it, do your front numbers, do your powers of 10, follow your exponent rules, adjust it if you need to. Okay, we've got to make sure our answer ends up in scientific notation. All right, now let's look at multiplication because they have some similar things going on. Oops. So let's say we had 3 times 10 to the 4th, and we're going to multiply that times 2 times 10 to the 9th. Okay, well, here's where we're going to use our commutative property to do some rearranging, right? So this is all multiplication, so I can rearrange this so that I'm multiplying my front numbers and I'm multiplying my powers of 10. Okay, so I end up with 3 times 2 is 6. 10 to the 4th, 10 to the 9th. Again, our rule is we add exponents, and we get 10 to the 13th. Okay, and that is in scientific notation, right? You've got that first number is at least 1 less than 10, okay, times 10 to an exponent. All right, so that one's pretty straightforward. Again, we just multiply our front numbers, multiply our powers of 10 together, rewrite in scientific notation. Okay, now it doesn't always work out that nicely. Let's look at an example of where we don't. Say I had 3 times 10 to the 5th, and I want to multiply that times 4 times 10 to the 6th. So again, we rearrange our front numbers, group them together, group together our powers of 10, and we end up with 12 times 10 to the 11th. Again, we want to add our exponents. Okay, now that's not in scientific notation, right? Again, that front number is too big. It's got to be less than 10. At least 1 less than 10. So let's take a look at that. So we got 12 times 10 to the 11. So similar to when we divided, we're going to have to make an adjustment here. Okay, so we want to take that number 12 and we want to rewrite it in scientific notation. That's the part that's getting messed up here. So 12 is equal to 1.2. If I put my decimal point there, I have to move it right one spot. So that's times 10 to the 1st. Okay, so 1.2 times 10 to the 1st times 10 to the 11th equals 1.2 times 10 to the 12th power. Okay, now you'll notice in the ones I have to adjust, right, if I compare my two exponents, 11, 12, right, we'll notice that it is just a plus 1. Okay. Now if we think back to what we talked about with division, let me go back there. Okay. Oops, that's not what I want. Sorry about that. All right. When adjusting with division, we want to decrease by 1. So we see with multiplication that when we have to adjust, right, we're just going to adjust by adding 1. Okay, so when you're multiplying, again, we multiply those front numbers, multiply those powers of 10. Okay, sometimes it turns out the answer is in scientific notation. Right? If it isn't, and again, there's our example. If it isn't, okay, we need to make that adjustment, and our adjustment is we add 1 exponent. So if you need to adjust, or if adjustment is needed, we add 1 to the exponent. Okay, and if you forget that, you can always just work it out longhand, right? But it's kind of nice to kind of see patterns and use those patterns to make math a little bit easier, which is why we talk about the pattern first and not just give you the shortcut. Because if you understand the pattern, right, you can see why the shortcut works. It just makes it easier to remember and it makes a lot more sense. Okay, so that is multiplying and dividing exponents. Okay, again, always make sure your answer ends in scientific notation. So that's how we started with the number. So, you know, if it doesn't, you've got to make that adjustment, whether you are dividing, which you take away 1, or you are multiplying, in which you have to add 1 to that exponent.